So for my molecule, I chose to look at this cobalt complex. It is a D6-oxo complex, which has previously been proposed as an intermediate in various reaction mechanisms along with other high-valence metal-oxo complexes. However, due to the high valence occupancy, they're very unstable typically, and you can't isolate or characterize them. So this group chose to use this tris-imidazole 2-ylogene borate ligand, which has 3 strong carbene donors. So these carbene donors are able to stabilize the sigma bonds with the metal, as well as raise the antibonding orbital energy, increasing the d-splitting and leading to a low spin state, which stabilizes the complex as a whole. So moving over to my orbital diagram, on the left are the cobalt orbitals, and then on the right we have the NHC salx as well as the PZ from the 2p orbital of the oxygen. So the paper showed that the DZ square has sigma antibonding relationship with the PZ from the oxygen atom. So I showed that bond going down a little bit because of the weak sigma donor properties of the oxygen. And then the salx have very strong donor relationships. So the E salx can mix with the XY and the XZ and the YZ E symmetry orbitals from the 3D, just based on how they line up geometrically in space. So this raises up the XZ and the YZ Z orbitals to the 3E position here, and then stabilizes the 2 salx down here to the 1E, creating a very strong sigma bond and a large d-splitting based on the antibonding orbitals. So then the A salx here will mix with the other asymmetry here, the S, leading to this high antibonding orbital as well as this very stable sigma bond here. So then from there, moving on to the pi interactions. So the px and the py orbitals from the oxygen are occupied and align with the xz and the yz orbitals from the cobalt. So because of this, they'll raise up the energy a bit more in a pi antibonding interaction, and then lower the energy of these 2 orbitals to form 2 pi bonds. So this increases the bonding order of the cobalt and the oxygen to 3, showing that proposed triple bond here, and validating the structure. So this molecule also shows oxygen and hydrogen atom transfer reactivity, which was studied by the group using this oxygen atom, and then it also has a very strong metal-oxygen bond as shown by the high bond order of 3 here.